So this is my perturbation and this is my system, and we have to calculate first order energy correction in first excited state. In first excited state. Okay. In first excited state. So what do you have to do? You have to just go for first order energy correction in first excited state. So what will be your energy eigenvalue? So your energy eigenvalue is Em, and I am using this small mass m for your quantum number, and that value is equal to what? M square h cut square upon 2 capital M R square. Capital M is the mass of particle. So this is 2 mr square. And what will be energy eigenfunction? The energy eigenfunction is 1 upon root 2 pi e to the power I m phi. And what is value of m? The value of m is equal to 0, plus minus 1, plus minus 2, and so on. So when we are talking about first excited state, that means I am talking about m is equal to plus minus 1. So we have two indexes. So I can take phi plus, and this value is equal to 1 upon root 2 pi e to the power I phi, and phi minus is basically 1 upon root 2 pi e to the power minus I phi. And for both this energy eigenstate, we have energy eigenvalue, and that value is equal to, I will put m is equal to plus 1 or minus 1, we will get the same value, and that value is equal to h cut square upon 2m r square. So this is your energy eigenvalue associated to these particular eigenfunction. So now, can anybody tell me what will be my h naught? h naught क्या होगा? h naught को हम किसकी बेसिस में लिखेंगे? बताइए, phi 1 और phi 2 के बेसिस में, है ना? और h naught को phi प्लस और phi माइनस कर दो. इसको आप 1 भी कह सकते हो, इसको आप फर्स्ट वेव फंक्शन, इसको आप सेकंड वेव फंक्शन भी कह सकते हो. ओके, सो वी हैव टू राइट इट इन basis of phi plus and phi minus. So what will be h naught? Diagonal होगा या फिर off या फिर diagonal नहीं होगा? In this basis, that will be diagonal matrix. So eigenvalue आपके diagonal term में आ जाएगा. So 2mr square 0 0 h cut square upon 2mr square. So this will be your h naught. Now we have to just calculate our W dash matrix. So what is your W? Your W is this one. So you have to write this matrix in a basis of phi plus and phi minus. So we have to calculate how many term from there? कितने term calculate करने पड़ेंगे? 4 term. So let's try to calculate these 4 terms. So but before that, let me simplify this HP. This HP is equal to V naught by 2 3 1 plus cos 2 phi by 2 minus 1. So we can write it something like this, isn't it? Everyone is comfortable? So what will be this value? So this value is equal to, so, and you can also write this cos 2 phi as e to the power I2 phi or e to the power plus e to the power minus I2 phi if you needed some further simplification. But right now, let's try to go for our first matrix element. So what will be your first matrix element? So first matrix element is V or W dash 1 1. इसे क्या लिखेंगे? Phi plus W phi plus. So when you will write this particular thing, what will be my phi plus? किसका bra होगा? So that will be negative sign ना? Yes? 1 upon root 2 pi e to the power minus phi W. So that value is equal to V naught by 2, and this value is 3 by 2 1 plus cos 2 pi minus 1. Okay. And what will be your phi plus? क्या होगा phi plus? E to the power I phi 1 upon root 2 pi d phi. कहां से कहां तक इंटीग्रेट करोगे? 0 to 2 plus 2 pi. So fortunately, what will happen? E to the power I phi and e to the power minus I phi, that will cancel out, and 1 upon root 2 pi will go outside, and this V naught by 2 is also going outside. So what we have? 1 upon 2 pi into V naught by 2 is there. And what we have? We have basically 0 to 2 pi, and this will compensate to each other. So that will be 1 by 2 d phi plus 3 by 2 cos 2 phi d phi 0 to 2 pi. What will be cos 2 phi d phi 0 to 2 pi? That is 0. That is 0. So that value is equal to 0, and that value d phi is nothing but 2 pi by 2. So 1 upon 2 pi into V naught by 2 into 2 pi by 2. So 2 pi is cancel. We have V naught by 4. So my first matrix element is all about V naught by 4. Now, can you please tell me what will happen to 2 matrix? W dash 2 also? If I want to write W dash 2, then what I have to do? I have to go for minus sign. I have to go for minus sign. Then this will be plus and this will be minus, isn't it? And again, you are getting the same answer, isn't it? देखो, degenerate perturbation theory में आप हमेशा एक चीज का ध्यान रखोगे, and that is very important, that how you are doing integration. सारे एलिमेंट को कैलकुलेट करने की जरूरत नहीं होगी. You have to see the symmetry. Unless until you will not see symmetry, it will take a lot of time. Because अगर 3x3 मैट्रिक्स है तो 9 एलिमेंट निकालने पड़ेंगे, 2x2 मैट्रिक्स है तो 4 एलिमेंट निकालने पड़ेंगे. So just try to see symmetry and write the answer. So you have to be very much smart. You have to do very much smart calculation. Okay. So I think V22 and V11 is all about V naught by 4. Okay. So that is your V naught by 4, V naught by 4. Now, next is very interesting. Next हमें क्या calculate करना पड़ेगा? V12 and V21. Both will be, obviously we know that W dash will be symmetric matrix. So we have to just go for this particular calculation. So let's try to go for V12. And this calculation is really very nice. W dash 12. So that value is equal to 5 plus, and that value is V naught by 2, 3 by 2, 1 plus cos 2 phi minus 1. Okay. So this is your, and here is you have phi minus. So how we will go for this? We can take V naught by 2 common. So I am using this space, V naught by 2 common. Integration, what is bra phi plus? 1 upon root 2 pi e to the power minus I phi. This is very interesting. And now V naught by 2 I have taken common. And first term is 3 by 2 minus 1. So this term is basically 3 by 2 is minus half e to the power minus I phi d phi 0 to 2 pi. So I have just taken this first term. Now let's go for second term. So when you will go for second term, and this V naught by 2 will be outside this, and 1 upon root 2 pi is also there. Okay. Good. Now second term is 0 to 2 pi, and we have 1 upon root 2 pi e to the power minus I phi. And what you have? You have cos 2 phi. So we have cos 2 phi with 3 upon 2 and 1 upon root 2 pi e to the power minus I phi d phi. Okay. So now what is going to this calculation? ये calculation की क्या value होगी? Anyone? E to the power minus I 2 phi, 0 to 2 pi. What will be that integration?
So 0.
0. So that value is 0. So e to the power I 2 phi, e to the power I 4 phi, e to the power I 6 pi, all the even multiple, e to the power I even multiple of phi, 0 to 2 pi will always 0. So we have to take care of this particular statement. Now we are going to simplify this particular thing. So this value is basically, I am using this space actually 0 to 2 pi and 1 upon 2 pi is there and V naught by 2 is also there. 1 upon 2 pi e to the power minus 2I phi and here 3 by 2 and this cos 2 phi can be written as e to the power I2 phi plus e to the power minus I2 phi upon 2 d phi. So this 2 and this 2 will also go outside and this 2 pi 1 upon 2 pi will also go outside. So I am using this space. Okay. Now अब ये देखो इसको मैं सिंप्लीफाई कर रहा हूं. सो V naught upon this 2 pi and 3 will come outside. So 3 upon 2 into 2 into 2 pi. And now you can have e to the power minus I2 phi and e to the power I2 phi. That value will be cancelled out and we have d phi. Isn't it? And e to the power minus I2 phi, e to the power minus I2 phi, that value is equal to plus e to the power minus 4I phi d phi 0 to 2 pi 0 to 2 pi. So now what will happen to this integration? 0. This integration will 0. So ये मैं deliberately क्लास में कर रहा हूं कि आप देखो कैलकुलेशन बहुत आसान है लेकिन कहां कॉस को ओपन करना है कहां कॉस को नहीं ओपन करना है, इट इज वेरी इंपॉर्टेंट. So this value is equal to 0 and what will happen to this one? एक और 2 होना चाहिए ना, and this 2 will be also there. So there is 1 2 is also there. Okay, this integration is 2 pi. So you have 3 V naught 8 into 2 pi into 2 pi and that value is equal to 3 V naught upon 8. And once you will go for V12 and V21 and you all know that this is symmetric matrix. So this element is basically 3 V naught by 8 and the value is 3 V naught by 8. Wonderful problem. So now you have calculated all this thing and you have to do very smart calculation. और कहीं आप गलती से यहाँ पर integration by parts में फंस गए, then it will take a lot of time. So you have to be very much smart where you have to open the cos function or not open the cos function. Okay, clear है ना? So now अब हमें क्या करना होगा बताइए? What is my next target? So H naught हमने निकाल लिया. What is my H naught? H naught is equal to, let's say, E naught 0 E naught plus we have this particular W matrix, that is V naught by 4, 3 V naught by 8, 3 V naught by 8, V naught by 4, and don't worry, E naught is all about H cut square upon 2m R square. So I have deliberately written this thing. So now it will just go into that problem which we have started in our first class of the degenerate perturbation, isn't it? So what do you have to do? You have to just find the eigenvalue of this particular matrix. So because it is diagonalized, W dash is equal to W and we have to find the eigenvalue, that is V naught by 4 minus lambda whole square minus 3 V naught by 8 whole square must be 0. So lambda is equal to V naught by 4 plus 3 V naught by 8 and second this is your lambda 1 and this value is equal to 8. 2 V naught plus 3 V naught is equal to 5 V naught by 8 and lambda 2 is equal to V naught by 4 minus 3 V naught by 8. ठीक है ना? And what is this value? Minus V naught by 8. So you have this as your after perturbation, you will find this correction. So initially you have E naught, and after then perturbation, you will break into two parts. The first part is minus V naught by 8, and second part is plus V naught by 8. Okay, so this is your correction term into this particular problem. Okay, so it's a wonderful problem. It can come into your exam. ठीक है? कोई doubt है? Any doubt you have?
Sir,
बताओ.
sir, here E0 is you have taken E1 na?
E1.
Which
अरे
fraction?
E0 मैंने लिखा है, इस वैल्यू को E0 लिखा है भाई. क्या है ये?
Okay.
आप E1 कह दो, E2 कह दो, मैंने इसको लिखा है E0, है ना? h कट स्क्वायर बाई 2mr स्क्वायर को E0 लिखा है.
Okay.
ठीक है? Now we are going to most important question जो आपके एग्जाम में इन जनरल 2-3 बार से आ रहा है और बच्चे उसमें बहुत ही कंफ्यूज होते हैं. सो लेट्स ट्राई टू गो फॉर दैट क्वेश्चन, है ना? सो लेट्स ट्राई टू गो फॉर दिस वन. व्हाट we have basically a matrix, and this matrix is V naught 1 0 0 0 1 0 0 0 2 plus epsilon V naught, and you have minus 1 0 0 0 0 1 0 1 0. Now you can see this is 3 cross 3 matrix, but this is doubly degenerate. So it is very interesting problem. This is 3 cross 3 matrix, but here is doubly degenerate, and one is non-degenerate. So what we have a eigenvector phi 1 is equal to 1 0 0 associated with the eigenvalue V naught, phi 2 as 0 1 0 associated to the eigenvector V naught, but phi 3 is basically 0 0 1 associated with eigenvector 2 V naught. So for 2 V naught, we have to go for the non-degenerate perturbation theory. So what will happen for E3 1? I am just talking about this one. So E3 1 will be phi 3 W phi 3. That's it. Okay. So what will happen? So this value is equal to, I am just talking about correction about 2 V naught. Correction about 2 V naught, which is basically non-degenerate. This is basically non-degenerate. So what you have to do? You have to just use the non-degenerate perturbation theory for 2 V naught, and that value is equal to 0 0 1 and minus 1 0 0 0 0 1 0 1 0 0 0 1, and this value is equal to, first term is 0, second term is 1, third term is 0, and here you have 0 0 1, so that is 0. So there is not any correction up to first order. You can go for the second order correction, and you can easily use that same formula what you are using into non-degenerate perturbation theory. But now we have to go for the degenerate perturbation theory. यहां तक तो क्लियर है ना? यहां तक क्लियर है?
Yes, sir.
Everyone? Okay. Now we have to go for degenerate perturbation theory for V naught eigenvalue, and we have two eigenvector. So now we have to just think about 2 cross 2 matrix, because our perturbation into basically 2 cross 2 matrix. So I can write, so here we have phi 1 and phi 2. I can write it, let's say phi A, and I can write it, let's say phi B. And we have to write a W matrix in a basis of phi A and phi B, because the degeneracy is associated to phi 1 and phi 2, which I have deliberately written phi A and phi B. Suppose this H will be written something like this: V naught 1 0 0 0 2 0 0 0 1. Then you have to write W matrix in basis of what? आप किसके बेसिस में लिखते हैं W मैट्रिक्स? बताइए.
phi 1 and phi 3.
phi 1 and phi 3 के बेसिस में लिखते हैं. आर यू गेटिंग माय पॉइंट? सो यहां पर बेसिस का रोल बहुत ही ज्यादा इंपॉर्टेंट हो जाएगा कि जिस वेक्टर के साथ डिजेनरेसी एसोसिएटेड है उसी के बेसिस में आपको डब्ल्यू मैट्रिक्स लिखना है, बिकॉज इट इज वेरी इंपॉर्टेंट what is this subspace is going to this matrix, and this matrix is not the same matrix. Are you getting my point? यहां पर phi 1 और phi 3 का रोल इंपॉर्टेंट होगा और इसमें phi 1 और phi 2 का रोल इंपॉर्टेंट होगा. So you have to be very much careful in which basis you have to write W dash, and you have to write W dash in a basis where degeneracy is associated. अभी तक हम लोगों ने जितने भी प्रॉब्लम किए थे उन सारे प्रॉब्लम में क्या दिक्कत थी? उन सारे प्रॉब्लम में यह बात थी कि आपकी एच नॉट मैट्रिक्स में कंप्लीट डिजेनरेसी थी, कोई भी नॉन डिजेनरेट नहीं था. आर यू गेटिंग माय पॉइंट? बट हियर यू हैव अ डिजेनरेसी that is not happen into complete subspace. There is also non-degenerate part in that particular subspace. So now you have to write this W matrix in a basis of phi 1 and phi 2. मैं इसकी बात कर रहा हूं. सो जैसा आपका H नॉट रहेगा उस ढंग से आपको W डैश को लिखना होगा. सो नाउ फर्स्ट टर्म इज WAA. क्या लिखेंगे इसे? phi A W dash AA, that is phi A, and which is basically my phi 1 W phi 1. So what you will get? 1 0 0, and we have V naught minus V naught 0 0 0 0 1 0 1 0, and you have 1 0 0. So what you will get? Minus V naught 0 0, and you have 1 0 0. So you have basically minus V naught. So WAA, the first term is minus V naught. So I have minus V naught as this matrix. Now I will go for WAB, and WAB is equal to WBA, because we all know that will be always a symmetric matrix. W dash will be symmetric matrix. So here we will go B, here we have to go 2, and here we will go 0 1 0. And now the first term will remain same, the second term will be 0 1 0, and that value is 0. So that value is 0 here. Okay, now this value will be also 0. Now finally we have to go for 2 2. Finally we have to go for what? 2 and 2. So W dash BB, we have to go for B 2, and now you have to just write this thing as 0 1 0, and now this value is equal to, first term is 0 0, it is 0, and you have 0 1 0, that is 0. So you have this particular W dash matrix. So now your H naught matrix is 1 0 0 1 plus minus V naught 0 0 0. and here is V naught is there, and epsilon is also there. So what will be your correction? You have V naught plus epsilon into 0 and V naught minus epsilon into P naught. So you can easily use this particular doubly degenerate. Initially your energy is V naught, but after perturbation, this will be break something like this. That will be minus epsilon V naught and one will be remain same. So this is your perturb thing. So you have to be very careful about the basis vector when you are doing the degenerate perturbation theory. ठीक है?
सर लास्ट स्टेप्स बता दो सर ये
क्या हो गया?
सर लास्ट स्टेप्स
अब इसका आइगन वैल्यू कैलकुलेट कर ली, ये भी डायगोनल है, ये भी डायगोनल है, आइगन वैल्यू कैलकुलेट कर लो. नहीं
यू हैव रिटन दिस इज h ना
क्या?
दिस इज h you have written.
यस दिस इज एच नॉट.
ओके
अरे एच नॉट नहीं है ये.
यस सर यस ओके
और ये आपका नया मैट्रिक्स डब्ल्यू डैश का किसकी बेसिस में? ए और बी की बेसिस में. ठीक है? ओके चलो. So let's go for one more problem. So your H naught is given by 1 0 0 0 2 2 sorry 0 2 0 0 0 2 and your perturbation is epsilon 0 1 0 1 0 1 0 1 0. Now अब आप मुझे बताओ, you have to just find the energy correction for lambda is equal to 2. 2 के लिए करेक्शन करना है. So what is your phi 1? Phi 1 क्या होगा? 1 0 0. What is eigenvalue? E10 is equal to 1. What is your phi 2? बताइए. 1 0 1 sorry 0 1 0. And what is E20? 2. And what is your phi 3? 0 0 1. And you can write E201 and something like E202. That is 2. ये मैंने डिजेनरेसी के लिए लिखा, फर्स्ट डिजेनरेसी सेकंड डिजेनरेसी. ओके बिकॉज वैल्यू इज एग्जैक्टली सेम. नाउ अब ये बताओ W को किसके बेसिस में लिखोगे? phi 1 phi 2 phi 2 phi 3 या phi 1 phi 3? डबली डिजेनरेट तो 2 क्रॉस 2 का ही मैट्रिक्स होगा. किसके बेसिस में लिखोगे?
phi 2 phi 3
phi 2 phi 3. So first, so now I can write it, this is phi A and this is my phi B. So now what is your H naught matrix? Your H naught matrix is basically 2 0 0 2. This is your H naught matrix. And what is your, now you have to go for W dash matrix. चलिए फटाफट देखते हैं. Phi A W phi A. ठीक है? So phi A की जगह पर क्या लिखे? That is basically what? Phi 2 W phi 2. And that value is equal to 0 1 0. And what is your W? 0 1 0 1 0 1 0 1 0 0 1 0. When you are going to calculate it, क्या मिलेगा आपको? 1 0 0 and again is 0 1 0. Sorry, 1 0 1. This is 1 0 1 and 0 1 0. That is 0. So W dash matrix is equal, first element is 0. Now I have to go for AB. यहां पर क्या हो जाएगा? 2 and 3 and that value is equal to 0 0 1. ये तो ऐसा ही रहेगा and you have 0 0 1. So that value is equal to what? 1. So this value is 1. So obviously AB is equal to BA, so this is 1. And now you have to go for phi B, phi B. So W3 3 and that value is 0, 0, 1, 0, 0, 1, and sorry, you can easily calculate this one. So this value is equal to 0, 1, and 0, and you have 0, 0, 1. So that is 0. So this is your W dash. Now you have to just go for this subspace 2, 0, 0, 2 plus epsilon 0, 1, 1, 0. What will be eigenvalue of this matrix? इसका eigenvalue क्या होगा? Plus epsilon and minus epsilon. So you will get answer 2 plus epsilon and 2 minus epsilon will be the answer. The eigenvalue of this one is epsilon and minus epsilon. So this will be your answer. It's a very interesting. Okay. So you have to be always careful about the subspace. Where is your degeneracy is lies. Okay. ठीक है. So let's try to go for a last level of problem. यहां तक क्लियर है ना? और इस बार एग्जाम में आना चाहिए डिजेनरेसी से. बहुत दिनों से क्वेश्चंस नहीं आए हैं. ओके. सो यू हैव टू बी वेरी मच केयरफुल. Now, let's try to go for your energies E naught 0 0 0 0 E naught 0 0 plus lambda. Here you have V naught 0 0 0 V naught V naught 0 V naught V naught. Now, this is very interesting. This is very interesting. So now this is not diagonalized matrix. Are you getting my point? This is not a diagonalized matrix. And what is your eigenvalue? Your eigenvalue is E naught, E naught, and minus E naught. And what is eigenvector? Is 1 0 0 0 1 by root 2 1 by root 2, and you have 0 1 by root 2 minus 1 by root 2. Now here you have to take care of all this concept. Now what is your first duty? What is your first duty? अभी तक तो जितने भी प्रॉब्लम आपने किया था उसमें एच नॉट आपका क्या था? डायगोनलाइज था. फर्स्ट टाइम यू आर एनकाउंटरिंग वेयर एच नॉट इज नॉट डायगोनलाइज. आर यू गेटिंग माय पॉइंट? आप देख रहे हो एच नॉट आपका डायगोनलाइज नहीं है. देन व्हाट यू हैव टू डू? यू हैव टू फर्स्ट डायगोनलाइज एच नॉट इन दिस बेसिस. तो अगर आप इसकी बेसिस में एच नॉट को डायगोनलाइज करोगे तो क्या होगा? व्हाट यू विल गेट? बताइए. व्हाट विल बी योर एच नॉट? एच नॉट हमेशा अपने आइगन वेक्टर के बेसिस में डायगोनलाइज होगा. देन व्हाट यू विल गेट? द आइगन वेक्टर, सॉरी आइगन वैल्यू. Where you will get eigenvalue? So you will get E naught 0 0 0 E naught 0 0 0 minus E naught. So now you are getting this as your diagonal matrix. Then what is your S matrix? अगर ये आपका diagonal matrix है तो S matrix क्या होगा? So your S matrix will be 1 0 0 0 1 by root 2 1 by root 2 0 1 by root 2 minus 1 by root 2. And this is also equivalent to S inverse because this is unitary matrix. Some sort of rotation about this axis. Let's say this is x-axis, so this is rotation above the x-axis. Now this is your S inverse. Now what is your next challenge? What is your next challenge? What is your next challenge? अगला स्टेप क्या है?
So W dash निकालना है.
W डैश निकालना है. किसकी बेसिस में?
Eigenvector of H.
H means S के बेसिस में, है ना? So you will find W dash in a basis of eigenvector of S. So इसी के बेसिस में निकालोगे आप. And if you will calculate this particular thing, you will get basically V naught 0 0 0 to V naught 0 0 0 and 0. You will just try with yourself, you will get this one. And now my question is that why it is diagonalized in basis in the basis in which S H naught is also diagonalized? उसके बेसिस में ये क्यों diagonalize हो गया? रीजन क्या था? क्या W डैश हमेशा diagonalize मिलेगा? Yes or no?
No sir.
No. लेकिन यहां पर diagonalize मिल गया, उसके पीछे के रीजन क्या थे? क्या हो सकता है रीजन?
सर जो आइगन वेक्टर ऑफ H नॉट है वो
यस, जो आइगन वेक्टर ऑफ H नॉट है, फॉर्चुनेटली वही आइगन वेक्टर आपका W का भी है. आप इसको निकाल सकते हो. सो चूंकि आपने ऐसा प्रॉब्लम आपको दिया गया कि दोनों के आइगन वेक्टर क्या हैं? सेम है. सो यस, दिस इज ऑल्सो डायगोनलाइज्ड, दिस इज ऑल्सो डायगोनलाइज्ड. सो व्हाट इज योर, सो नाउ you are going to do this particular problem. Okay, so this is your H naught, and now your W dash is basically lambda time V naught 0 0 0 2 V naught 0 0 0 0, and fortunately you have diagonalized all this thing. And now what will be your answer? क्या हो जाएगा? E naught plus lambda V naught, E naught plus lambda time 2 V naught minus E naught plus lambda times 0. So you have before perturbation minus E naught and E naught, but as you will add perturbation, this minus E naught will remain same, but this will break into two level, and that value is equal to E naught plus lambda V naught and E naught plus 2 lambda V naught, and you are getting the exactly this particular answer. So you have to be very much conscious. अगर by the way W dash diagonalize नहीं होता तो क्या करते? अगर by the way W dash diagonalize नहीं होता तो क्या करते?
सर आइगन वैल्यू निकालते हैं.
अगर डायगोनलाइज नहीं होता तो आप क्या करते? फिर से W डैश जो आपने लिखा है ना, ये जो W डैश लिखा है इसको आपको फिर से देखना होता कि किस सब स्पेस में आपका डिजेनरेसी है ना. तो आपका ये प्रॉब्लम फिर से निकल गया. इसका अब इसके आइगन वैल्यू क्या हो गई? 1 0 0. इसके आइगन वैल्यू 0 1 0. अब जो W डैश को है उसको किसके बेसिस में लिखते? इस सब स्पेस के बेसिस में, phi1 और phi2 के बेसिस में, एंड देन यू विल फाइंड द आइगन वैल्यू. आर यू गेटिंग माय पॉइंट?
यस सर.
क्योंकि यहां पर फिर से देख रहे हो नॉन डिजेनरेट और डिजेनरेट है, दोनों का मिक्स है. तो क्या phi1 है, क्या phi2 है, ये तो आपको ध्यान देना होगा ना. So whenever mixed thing will come, you have to be very much careful. ठीक है. So this is, हालांकि इस तरह के प्रॉब्लम आपके एग्जाम में नहीं आएंगे, बट एनीवे मैंने एक स्टेप आपको ऊपर ही करके रखा है. इन जनरल आपके एग्जाम में H0 जो है वो डायगोनलाइज ही होंगे, सो डोंट बॉदर अबाउट दिस थिंग. आपको किस तरह से अप्रोच करना है प्रॉब्लम को, वो बहुत ही ज्यादा इंपॉर्टेंट है. ऑलवेज यू विल सी दैट पार्ट ऑफ द वेक्टर which is associated to the degeneracy. This is very important thing, and you have to write the W matrix into that basis. ठीक है. यहां भी आप वही चीज किए हो, लेकिन उसकी जरूरत नहीं पड़ी क्योंकि ये डायगोनलाइज है, तो 1 0 0 किसी लिखते तो फिर से यही मिल जाता, तो देयर इज नॉट एनी प्रॉब्लम. क्लियर है ये, है ना? चलो, सो आज के लिए इतना ही रहने देते हैं, एंड नेक्स्ट क्लास में हम लोग बात करेंगे टाइम डिपेंडेंट पर्टर्बेशन. ओके
सर सर मेरा एक बहुत छोटा सा डाउट है ये चीज. जब आप प्रोडक्ट कर रहे थे वो वेक्टर्स को, दैट मैट्रिक्स को, तो वो आप प्रोडक्ट डायरेक्ट प्रोडक्ट कर रहे थे?
नहीं, इनर प्रोडक्ट कर रहे थे भाई. डायरेक्ट प्रोडक्ट क्यों करेंगे? कॉलम इनटू मैट्रिक्स.
सर आप
रो इनटू मैट्रिक्स भाई. रो इनटू स्क्वायर मैट्रिक्स इज रो.
सर वो पता नहीं, वो आंसर
क्या है?
आ नहीं रहा था मेरा, मतलब मैं शायद दोबारा चेक करूंगी सर. थैंक यू.
आप सिंपल है, देख लो ना, इसमें सोचना क्या है. सपोज 0 1 0, यही तो था. मान लो ऐसा है, सपोज ये करना है, तो पहले इसको इसके साथ करो, इसको इसके साथ करो, इसको इसके साथ करो. यही तो करते हो, और क्या करते हो? इसको इसके साथ करोगे तो क्या आएगा? पहला एलिमेंट 1, इसके साथ करोगे 0, दूसरा एलिमेंट 1. नहीं, ये इससे मल्टीप्लाई होगा, ये इससे मल्टीप्लाई होगा, ये इससे मल्टीप्लाई आएगा, 1 आएगा. 0 इंटू 0 प्लस 1 इंटू 1 प्लस 0 इंटू 0 1. चलो, इसको इसके साथ मल्टीप्लाई करो. 0 इंटू 1 बोलो.
0 0 एंड 0 आएगा. 0 1 एंड 0 आएगा.
0 इंटू 1 इज 0, 1 इंटू 0 इज 0, 1 इंटू, ठीक है, 0 इंटू 1 इज 0, तो ये 0 आ गया.
यस सर.
थर्ड वाला ये आ गया. ठीक है.
यस.
और फिर इसको करो 0 0 1. अब इसमें कोई रॉकेट साइंस है क्या?
नहीं सर, वो पता नहीं आ नहीं रहा था आंसर. मुझे लगा आपने डायरेक्ट लिख दिया ना तो जल्दी जल्दी, तो मुझे लगा ये
कुछ जल्दी जल्दी नहीं लिखा, मैं ऐसे ऐसे करते जाता हूँ, मैच करता रहता हूँ, 0 को छोड़ता जाता हूँ. ठीक है. अब इसको मैं 0, मैं अब से भी 1 वाले को देख रहा हूँ कि 1 किसके साथ मैच करेगा, इसके साथ मैच करेगा, इसके साथ मैच, किसके साथ थोड़ी मैच करेगा.
ओके
ठीक है. 0 वाले को मैं ध्यान ही नहीं देता हूँ. ठीक है. तो डायरेक्ट जल्दी नहीं लिख रहा हूँ, कुछ दिमाग के अंदर चल रहा है. ठीक है.
ओके
ओके, चलो, थैंक यू.